Hello everyone, this is Neetu Khatri. Welcome back to my channel. Let's learn with Neetu. I have already explained you about the whole numbers in our previous videos. In today's video, we will summarize the full chapter of whole numbers of class 6. The topics which we will cover are chapter summary of whole numbers, and we will do the exercise 2.3 of NCERT, and at the end I will provide you one practice sheet to do at home. Let's start the topic. Summary of chapter whole numbers. The numbers 1, 2, 3 and so on which we use for counting are known as natural numbers, as these numbers come naturally. When we start counting naturally, we start counting from 1. So, these are known as counting numbers or natural numbers. If we add 1 to a natural number, we get its successor. If we subtract 1 from a natural number, we get its predecessor. Every natural number has a successor, and every natural number except 1 has a predecessor. When we add 0 to the collection of natural numbers, we get the collection of whole number. That is, if we add 0 to the natural number, that is, if we start from 0, 1, 2, 3, 4 and so on, we form the set of whole numbers. Every whole number has a successor, and every whole number except 0 has a predecessor. All natural numbers are whole numbers, but all whole numbers are not natural numbers, since 0 is not a natural number. 0 is a whole number. To represent whole numbers on number line, we mark a point as 0 and then mark points at equal intervals to its right as 1, 2, 3 and so on. It means first we mark 0 and then to the right at equal distances we mark 1, 2, 3, 4 and so on. On this line, we can perform addition, subtraction, multiplication, comparison and many more operations. When we do addition on a number line, we move to the right. When we do subtraction on a number line, we move to the left. And when we do multiplication on a number line, we make equal jumps starting from 0. Students, if we want to learn in more detail, then you can check out my previous videos in my channel. I will provide the links of those videos in the description box also. You can go to these videos from the link provided in the description box also. This is the revision class or summary class of the chapter whole number. So students, I cannot explain it in more detail in this video, as I have to cover the whole chapter in this. Next, whole numbers are closed under addition and multiplication, meaning the result is always a whole number. However, they are not closed under subtraction or division. It means while doing the addition and multiplication, the order of the whole numbers is not necessary. Division by 0 is not defined. If we divide any number with the 0, the result is not defined. 0 is the additive identity and 1 is the multiplicative identity. It means if we add 0 to any number, we get the number itself, and if we multiply 1 with any number, we get that number only. Whole numbers are commutative for both addition and multiplication. That is, the order of addition and order of multiplication is not important. We can add or multiply in any order. The answer of A plus B is equals to B plus A, and the answer of A into B is equals to B into A. Whole numbers are also associative for addition and multiplication. That is, A plus B in bracket plus C equals to A plus B plus C in bracket, and A into B in bracket multiplied by C is equals to A into B into C in brackets. Multiplication is distributive over addition. That is, A into B plus C equals to A into B plus A into C. The commutative, associative and distributive properties of whole numbers are very useful in simplifying calculations. We often use them without realizing it. We usually use them, but we don't realize that we are using the properties, commutative, associative and distributive properties of whole numbers. Patterns in numbers are not only interesting but also help us perform mental calculations and understand number properties better. As students, I have not made the video of patterns in numbers, but I promise I will share the video of patterns in numbers very soon. Exercise 2.3 of whole numbers. Which of the following will not represent 0? 1 plus 0 equals to 1, that is, it is not 0. 0 into 0 is 0, as 0 multiplied by any number is equals to 0. So, the answer is 0. 0 to the power 2, it means 0 multiplied by 0. The answer will be 0. 10 to the raised power 2 minus 2, that is 100 minus 2. We get the answer as 98, that is not 0. So, A and D will not represent 0. If the product of two whole numbers is 1, can we say that one or both of them will be 1? Justify with example. If A and B are whole numbers and A into B equals to 1, then both A and B must be 1. Whole numbers are non-negative integers. The only factorization of 1 in whole numbers is 1 into 1. The factor of 1 is 1 only. For example, 1 into 1 equals to 1. There is no pair of whole numbers other than 1 comma 1 whose product is 1. So, 1 multiplied by 1 equals to 1. So, the answer is yes. If the product of two whole numbers is 1, then we can say that both the numbers will be 1. Next, find using the distributive property. 728 into 101. We can write 101 like 100 plus 1. So, we will distribute 728 to 101 both. We get 728 multiplied by 100 plus 728 multiplied by 1. We get the answer as 73,528. In next, we can write down 1001 as 1000 plus 1. Now we can distribute 5437 to both 1001. We get the answer as 54,42,437. And next we can write down, in the next question we can write down 25 as 100 divided by 4. So we get the answer as 20,600. In next question we can write down 125 as 1000 divided by 8. So we get the answer as 5,34,375. In next we can write down 35 as 30 and 5. Then we will distribute 504 to both the numbers and we get the answer as 17,640. Study the pattern. Write the next two steps. Can you see how the pattern works? The hint is given 1, 2, 3, 4, 5 equals to this pattern. From the pattern we can write the next two steps as 1, 2, 3, 4, 5, 6 into 8 plus 6. We can observe from the pattern that if the number is 1, 1 is multiplied by 8 plus 1, we get the answer as 9. Then the next number is 1, 2, that is 12 into 8 plus how many digits are there? There are 2 digits. So we must add 2 to the answer. In the next question we have 3 digits 1, 2, 3. So we add 3. Next we have 4 digits, so we add 4. We have 5 digits, so we add 5. So the next step will be 1, 2, 3, 4, 5, 6 multiplied by 8 plus 6. And in the result we have the decreasing series from number 9. And the next step will be 1, 2, 3, 4, 5, 6, 7 multiplied by 8 plus 7. And the result will be 9876543. Look at the numbers on the left. We have 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5 and so on. Each time one more digit is added in order. When you multiply by 8 and then add the same last digit, the result becomes the reverse. We get the reverse series from 9. Number go down from 9 to 1 step by step. I hope you have understood the summary of the chapter whole numbers. And students, this is the practice sheet. You all can do the practice at home, and if you want I can provide you the answers. I hope students you all have understood the topic clearly. If so, then please do like, share and subscribe my channel. Thank you. Bye bye.